Okay, I'm going to do part 2 of this paper, which is a continuation of this Edexcel IGCSE physics exam. I did part 1 and I covered a question on astrophysics and one question on forces in motion, and I'm now going to go to question 2. So if you watched the first video, you found it useful, make sure you like and share it with your friends. It really helps the channel with the YouTube algorithms, and I'm looking to expand the channel so more students get this kind of help in preparing for their exams. So these are the first 2 questions we went through already, and here's question 3, which is on electricity. I'm redoing this with headphones to see if the sound quality is improved. Okay, so the photograph shows a mains operated, which means 240 volts AC decorative lamp. Lamp X has 7 identical bulbs shown that are connected to each other in series. So they're giving you the scenario, and you've got to give it a disadvantage of connecting the bulbs in series, where the main one is if one bulb goes out, they all stop working, and that's a known disadvantage of series circuits. An advantage is it's a simpler circuit to wire up, and if you want to find the mark scheme, which you can find, they're available online, you can see that there will be alternatives to the advantages of connecting them in series. I can't remember all the other things they'll accept, so if you want to make sure that you've got if you've got something else written down and you want to make sure that you deserve a mark or not, you can download the mark scheme and have a look. Just put in the year of the exam and the code of the exam and you should be able to find it. Okay, so each bulb has a working resistance of 390 ohms, it says, and you can see that I've put 2 significant figures in brackets. That's to explain to you how you know how many significant figures you should be using in your answer. It then tells you the voltage is 33 across each bulb, so that's again 2 significant figures. They then want you to write down the formula linking voltage, current and resistance. I've put it as symbols because I'm just going through the answer quickly, but I'm making sure that they know that I know that the voltage is V, the current is I, and the resistance R. But you should really write it as a word equation in your exam to be sure that you get the 1 mark. Okay? But if you do it the way I've done it, I think they'll give you the mark. So then they want you to calculate the current in each bulb. Yes, that's each individual bulb, because remember 33 volts is how much each bulb gets of its share of the mains electricity, divided by the resistance using this equation. Put the numbers in correctly, you'll get 1 mark, and then you will then get another mark for quoting it to 2 significant figures. Okay? I don't know where the 3rd mark is going to come from. You'll have to look in the mark scheme. I think it says 3 marks there underneath the green line. Yes, 3 marks. So presumably you get 1 mark for rearranging the equation, perhaps change it from V equals IR into the form that I've put it in the box underneath as I equals V over R. So you could get 1. So it's quite generous mark for that. Okay. The next question wants you to calculate the energy transferred to the lamp. Yeah. When it is used for 2.5 hours. Well, to use the correct equation, it's one of the original equations that you were given on the equation sheet. Yeah. So when you do that, yeah, this equation is on the formula sheet at the front of the exam. Anyway, this year you probably will get all the equations. You've got to change hours into seconds. That means multiplying the hours by how many seconds that would be. That gives you 9,000. So if you put the 9,000 in, it will give you the correct answer in joules. If you don't, yeah, you will not get the answer in joules, and there will be some other units which you'd have to explain, and you won't get full marks, because remember, you're getting 4 marks. So 1 mark for changing the units to seconds, 1 mark for using the correct equation, putting all the numbers in, yeah, and then 1 mark for getting the answer for 1 bulb. Remember, the lamp X, this is just for 1 bulb, because 33 volts is how much 1 bulb uses. So you'll get it approximately 25,000 joules for 1 bulb, but remember lamp X has 7 bulbs, so they're talking about energy transferred to all of the lamp. So you've got to multiply the energy you calculated by 7, and that's the fourth mark, 176,000 or greater. So to two significant figures, remember, we know how many significant figures we should quote to. You shouldn't put the accurate value, you should just put 180,000 to two significant figures, or at the most you should put 177,000 to show that you've rounded it up and you know that the other figures on the calculator are just mathematical, but they're not really significant from the point of view of accuracy. It then goes into part D, so we know that they want you to do some further work on it, and they want you to compare lamp X with another decorative lamp, that lamp Y, which uses 5 of the same identical 390 ohm bulbs, and again connected in series. So again, you see the way I'm highlighting it, I make sure I've absorbed the information in the question, so I'm not misinterpreting what they're saying. Obviously both lamps are mains operated, so they're giving you all the facts you need to know, and they want you to explain, explain how the brightness of a single bulb in lamp Y compares to the brightness of a single bulb in lamp X. Well, in lamp X, each bulb got 33 volts because there were 7 of them. Now, bulbs in lamp Y will be brighter than in lamp X. So compare means say both sides of the comparison. Comparison means you're comparing two things, so make sure the examiner knows that you're talking about the comparison. Because each bulb in lamp Y, will get a greater voltage, than in X. Makes sense? So because obviously there's only 5 of them to share the 240 volts compared to 33 volts in the 7 bulb lamp. So the current will be also comparatively greater, so it will also be comparatively greater in Y. Why? Because the resistance of each bulb is the same, but the voltage is more. So the total energy transferred to each bulb will be greater because of E equals IV VIT. Obviously it's for the same amount of time, and each bulb gets the same amount of current because they're in series, and the current everywhere in a series circuit is the same. Therefore, any of these 4 points will get you a mark. So there's 3 from this list, and you'll get the mark. This question is out of 13. So electricity is topic 2 in the IGCSE. And then we're going to do another question, which is also on electricity. This time it's about a hairdryer, and it's also to do with the main supply. The graph shows a hairdryer plugged into the mains supply, and this time the hairdryer contains a fuse. So it looks like we're talking about safety features, fuses, etc. Okay, so they're going to ask you about the safety feature of fuses and how they operate. Which wire in the hairdryer should be in series with the fuse? And of course you need to know that in the mains you have the live wire, you've got the neutral wire, and you've got the earth wire. Okay, so another safety feature. So the live wire is brown in color, so don't forget to show that you know as much as you can. So I put in brackets. So you want the fuse always to be on the live wire, because the live wire is the dangerous wire. It's the one that's bringing in the current, if you like. Okay, the neutral wire is neutral, and it gives, the neutral wire is always kept at 0 volts, whereas the live wire is the one that fluctuates between positive and negative, and it's live. Okay, so the name tells you the important features of mains electricity. So the fuse is an electrical safety feature used in mains operated domestic appliances. State 2 other safety features that can be used in mains operated domestic appliances. Well, obviously we've already talked about the earth wire. If something goes wrong, the earth wire gives a shortcut back down to earth. Earth is also considered to be a neutral wire, and except the difference between the earth and the normal neutral wire is to get to the neutral wire you've got to go through the appliance, but to go to the earth wire you can go directly without going through the appliance. It's a connection from the casing of the appliance to directly to earth, so it shortcuts the circuit, increases the current substantially, and by doing so it doesn't need to go through resistance. That's why it increases substantially. The current suddenly shoots up and that melts the fuse by getting it too hot. So the earth wire is one of the points. The other point you can put is insulated cables or double insulation. Anything to do with insulation in this part of the question will get you another mark for safety features. And you could also put circuit breakers as a third option for this 2-mark questions. The first two points you put will get you the marks, so don't put more than 2 safety features because they'll only mark your first 2 answers. Okay, so always put your best guess in. Okay, and then the hairdryer has a current of 9.6 amps, so that's quite a high current. The mains supply voltage on average is 230 volts, because remember it actually goes positive, negative, positive, negative. So it's a special form of averaging, because obviously if it's positive and negative, the actual middle value will be 0. So the mean, the normal mean, will be 0. But there is another way of calculating the effective voltage over a whole cycle, and it's called the RMS value. And when you do A-level, you definitely need to know that. And it's like you've got rid of the negatives, so you actually square it all to get rid of the negatives, and then you take the average of the square values for those of you who want to get to high level or preparing for A-level physics, and then you take the mean of the square root of the squares, if you like, and then take the positive value, and that's what 230 volts mains AC actually is. So it's not the peak value, it's not the normal average, it's called the RMS value. It's the effective voltage that you would get if you replace the mains with a DC value of voltage. And that's a little bit above GCSE level, but I'm preparing you and I'm teaching you physics to a higher level than you may have got in your lessons. Alright, so they want you to state the formula linking power, current and voltage, and if you do that correctly with the word equations, you will get this equation here, where power is in watts, current is in amps, and voltage is in volts. So you need to now use that to calculate the power. We were given the voltage above, we were given the current. Each one was given to 2 significant figures, if you remember. 2 significant figures is the answer required. So if you do multiply them together to 2 significant figures, you get 2,200. You got to put the units in. You need to know that it's watts, which is how many joules it uses per second. And then it says the hairdryer contains a coil of wire which is used to heat air passing through the hairdryer. Explain why the coil of wire heats up when there is current in it. Okay? Now, as you know, current causes heating due to the resistance of the wire, and the actual type of wire that they use in things where they want to produce heat is nichrome, because nichrome produces quite a lot of heat, and it's the same wire that you've got in your toaster when you make your toast at home. It also uses nichrome wire. Explain why the coil heats up when there's current in it. So current is the flow of charge through a resistance wire. So that's the basic fact. As electrons travel through the metal, the lattice, the ions, if you like, they transfer kinetic energy to the lattice ions by colliding with them. That's another mark. So 1 mark is also for realizing that resistance is the key term. So resistance is one of the things I look for. That collisions transfer kinetic energy to the lattice structure, and how? By colliding with them. And this increases the lattice vibrations, which is what thermal energy actually is. Thermal energy is the molecular vibrations of the material, which you studied in solids, liquids and gases in Unit 5. Okay, so we're coming through to the final part of this question, and you have to explain how a fuse protects a domestic appliance. Okay, so if a fault occurs, yes, as I explained to you before, the current increases dramatically as a result. Okay, now when you have a fuse, you must also have an earth wire. Okay, and what happens is it will increase the current suddenly. The fuse wire gets too hot and melts the wire. So they want you to know that the fuse is made of a wire, and you could say the fuse blows. Okay, to show that you know the fuse will blow because the current increases above its capacity. Yeah, they're designed to be able to take a certain amount of current. For the hairdryer, it'll be a 13 amp fuse, and of course when the fuse breaks or melts, it also breaks the circuit which stops the current. Yeah, so those are the 3 points that you need to make. So both these questions are on mains electricity, so that's a really good revision for your mock exam. Hope you found that useful. Please make sure you show your appreciation. Want a like on every video. Just hit that like button and share it with your friends so we get more viewers, and subscribe, and I will do the next video shortly. Thanks for watching. Bye for now. See you in the next video.